Okay, my dear students, welcome. So, today in this video, we will find the Fourier series of a given function. And then we will use this Fourier series to deduce some special series. Okay, so let us start with a question. Let me take a question. Let us say, obtain the Fourier series of, let us say, the function fx, which is defined as x minus x square over the interval minus pi to plus pi, right? And deduce the series 1 by 1 square minus 1 by 2 square, right, plus 1 by 3 square, alternate positive and negative signs, and so on. This should be equal to pi square over 12. Okay, so this is our question. So, sorry, let us start with the first Fourier coefficient, that is a naught. So, to use the formula, we should know the value of L, which is defined as b minus a divided by 2, where a and b are the endpoints of your interval over which the function is defined, right? So this will give you pi minus minus pi divided by 2, because a is equal to a is equal to minus pi and b is equal to pi, right? So this will become 2 pi divided by 2, that gives you pi. So the value of L is equal to pi. Then let us calculate a naught. A naught is 1 by L integral of the function fx dx over the limits a to b, right? So let us put the values here itself. L is equal to pi, so we can put here, we will replace L by pi. A is equal to minus pi, so I am replacing a by minus pi, and b is equal to pi, so we will replace b by pi. And my function is x minus x square, so this fx I am putting as x minus x square. This is a very simple integral. You know how to do this. Integration of x will be x square by 2 minus x square. Integration will be x power 3 over 3 with the limits minus pi to plus pi. And when you put the limits and you simplify, you will get the value of a naught as minus 2 pi square divided by 3. This is a very simple calculation, so I am leaving it to you. Okay. Now, then we will go to the second Fourier coefficient, that is an, which is defined as 1 over L integral a to b fx cosine n pi x divided by L dx. Again, put the values. L, what is our L? Pi. So I am replacing this L by pi. I am replacing a by minus pi. I am replacing b by plus pi. I am replacing fx by x minus x square. And again, cosine n pi x by L. L we will replace by pi. And here you will see that pi gets cancelled with pi. Now, this is a normal integration by parts. You know how to do this. So I am writing the integral directly. I am confident that you know how to do integration by parts. So this integral will become x minus x square sine nx divided by n minus 1 minus 2x minus cosine nx divided by n square and the third term will be minus 2 minus sine nx divided by n power 3 over the limits minus pi to plus pi. When you put the limits, when you put x equal to pi, this will become sine n pi, which is 0. And if you put x equal to minus pi, then also this will become sine of minus n pi, which is also 0. So in both cases, this first term will become 0. Whether you put the upper limit pi or you put the lower limit minus pi. In both cases, this first term will become 0. So we can cancel it here itself. Same thing will happen to the third term also. Minus 2 multiplied by minus sine nx over n power 3. So again, when you put the upper limit pi, x equal to pi, this will become sine n pi, which is 0. And same thing when you put the lower limit minus pi, so it will become sine minus n pi, that is also 0. So this third term also, in both cases, this will become 0. So you can cancel it here itself. So we are left with only the second term, which is minus 1 minus 2x multiplied by minus cosine nx over n power 2. So when we simplify, you can take this n square outside the bracket. So this becomes 1 over pi n square, and inside the bracket whatever is left, we will put the lower limit and the upper limit. And because this is a multiplication, so this minus and this minus, this will turn into positive, right? So let us put pi first. So we get 1 minus 2 pi multiplied by cosine n pi, right? This is the first term which we are getting. And then we will put minus pi. So minus of, now we are putting minus pi, x equal to minus pi. So this becomes 1 minus 2 times minus pi, and this will become cosine n times minus pi, right? This is the second term. Okay. So this will further simplify to 1 over pi n square 1 minus 2 pi multiplied by cosine n pi. Cosine n pi is defined as minus 1 to the power n. And the second term becomes 1 minus 2 times minus pi. So this will become 1 plus 2 pi multiplied by cosine minus n pi. And we know that cosine of minus theta is same as cosine theta, right? So that minus sign will not make any effect. So cosine minus n pi will be same as cosine n pi, right? So what we get 1 over pi n square 1 minus 2 pi minus 1 to the power n, and this will become minus 1 plus 2 pi cosine n pi, that is again minus 1 to the power n. Further simplification will lead to 1 over pi n square, and if you want you can take this minus 1 power n as a common factor, so it goes outside the bracket. So minus 1 power n goes outside the bracket. Now inside we are left with 1 minus 2 pi, and we are left with minus 1 minus 2 pi. So this minus 1 and plus 1 will cancel, and finally you are getting minus 2 pi, that will become minus 4 pi, then minus 1 power n is there, and in the denominator we have pi n square. So again this pi and pi will cancel, so your answer is minus 4 minus 1 power n divided by n square. So this is the value of your an. Now let us move further and let us go to the value of bn. Now what is the formula for bn? bn is 1 over L integral from a to b fx. In an you take cosine, in bn we take sine. So sine n pi x divided by L. Put the values. L is equal to pi, fx is equal to x minus x square, a is equal to minus pi, and b is equal to pi. And this pi will cancel with this pi. So it will become sine nx. Now again, this is a simple integration by parts which I am leaving it to you. I am confident that all of you are capable of doing integration by parts at this level. So this will give us x minus x square minus cosine nx divided by n minus 1 minus 2x minus sine nx divided by n square, and the third term will become minus 2 times cosine nx divided by n power 3 over the limits minus pi to plus pi. Using the same argument which we discussed when we were calculating an, same thing will happen here also. When you put the upper limit pi equal to x in the second term, this will become sine n pi, which is equal to 0. When you put the lower limit minus pi is equal to x, this will become sine minus n pi, which is also 0. So in both cases, this second term will become 0. So we can cancel it here itself, and we can focus on our first and the third term. So we get 1 over pi. Let us put x equal to pi first. So we get pi minus pi square minus cosine n pi divided by n minus 2 cosine n pi divided by n power 3. This is one term minus, now we will put x equal to minus pi, which is our lower limit. So this gives us minus pi minus pi whole square or better I will write in the next line, otherwise it will not be visible on the same screen. Okay, so the second term I am writing in the next line. Okay, so we are putting x equal to minus pi, the lower limit now. Okay, so what we get, minus pi minus pi whole square minus cosine n times minus pi divided by n. Second term will give us minus 2 cosine n times minus pi over n power 3, bracket closed. Let us simplify further. Let's see what happens. This gives us 1 over pi minus pi square minus cosine n pi divided by n minus 2 cosine n pi divided by n cube and the second term will be minus pi minus pi whole square will become pi square minus cosine negative n pi, and we know that cosine of minus theta is same as cosine of theta. So cosine minus n pi will be same as cosine n pi divided by n, and the second term will give us minus 2 cosine. Here also we are getting cosine minus n pi, which is same as cosine n pi. So no issues. Divided by n power 3. Let us open the brackets, and I think many terms will cancel. Let us see. So this will become pi multiplied with minus cosine n pi over n. This is first term. Then minus, and this minus, this will become plus, right? So this gives us plus pi square cosine n pi divided by n. This is also fine. Third term is minus 2 cosine n pi divided by n power 3. Then the next line minus. Now, so this minus and this minus, again this will become plus, right? So this becomes pi cosine n pi divided by n, right? And again this minus and this minus, this is again going to become plus. So this becomes plus pi square cosine n pi divided by n, and the third term remains as it is, minus 2 cosine n pi divided by n power 3. Then if you see now, lot of cancellations will happen because we have a minus sign here, right? Or if you want me to write one more step for this to be more clear, I will write it. It is not required. You can cancel directly also. But if someone is getting confused, let me write it. No problem. So the first bracket is giving us minus pi cosine n pi by n plus pi square cosine n pi divided by n minus 2 cosine n pi divided by n power 3. And now let us open the second bracket. This minus is there. So it becomes minus pi cosine n pi divided by n minus pi square cosine n pi divided by n, and minus and minus becomes plus. So plus 2 cosine n pi divided by n power 3. What all will cancel? This pi square cosine n pi by n will get cancelled with pi square cosine n pi by n with minus, and same way minus 2 cosine n pi by n cube will get cancelled with plus 2 cosine n pi by n cube. And these two terms, they are same, so they will be added. So finally you are getting 1 over pi. This will become 2 times pi cosine n pi divided by n. And this pi will get cancelled with the pi in the denominator. So you are getting minus 2 by n cosine n pi. Cosine n pi is defined as minus 1 to the power n. So this is the value of your Bn. Now you are in a good position to write your Fourier series. Therefore, the Fourier series is, what is the formula for Fourier series? Fx is equal to a naught divided by 2 plus summation an cosine n pi x over L plus summation bn sine n pi x divided by L. You have both the values, or in fact all the three values you have. So we will put the three values which we have calculated in the above three steps. So let us substitute the values and let us get the Fourier series. Therefore, we get fx, which is defined as x minus x square, right, is equal to a naught divided by 2. We have evaluated a naught as minus 2 pi square by 3, and we have to divide by 2, right? So 2 will appear in the denominator, plus summation an. An we have calculated as minus 4 minus 1 power n divided by n square with cosine n pi x divided by L, that is again pi, plus summation bn. Bn we have calculated as minus 2 minus 1 power n divided by n with a sine n pi x divided by L, which is again pi. And if you see here, this 2 will get cancelled with this 2, and this pi goes with this pi, and this pi goes with this pi, right? So this is your Fourier series for this function which was given to you. So we have completed the Fourier series part. Okay. Now, after this, they have given us another task. What is that? That they want us to evaluate some series, some special series they have given us. Okay. Now, the interval is given as minus pi to pi. So let us try to use the midpoint of this interval. As you can see, the midpoint of this interval will be 0. So let us see what happens if I put x equal to 0 in my Fourier series. So the left side will become zero minus 0 square is equal to minus pi square over 3 plus summation of minus 4 minus 1 power n divided by n square cosine n times 0, that will become cosine 0, plus summation of minus 2 minus 1 power n divided by n sine n times 0, that will become sine 0. And we know that the value of sine 0 is equal to 0. So if you see the second series, the second summation will all become 0, right? So we are left with only the first two terms. Let us continue. This implies, so the left hand side has become 0 now. This is minus pi square by 3. And here you have, inside the summation, you have a constant minus 4, which you can keep outside. So this becomes minus 4 times summation minus 1 to the power n over n square, and cosine 0, which is always equal to 1. So this will be multiplied by 1, so that will remain same. This implies this part minus pi square by 3, you can shift it to the left hand side. So this becomes plus pi square by 3. And here you have minus 4. Now, if you open this summation, when you put n equal to 1, you will get minus 1 power 1, that will be minus 1 divided by n square, that is 1 square. Then you will put n is equal to 2. So it will become minus 1 power 2, that will become positive, divided by n is equal to 2 you have substituted, so 2 square. Then you will put n equal to 3. So minus 1 power 3, that will become minus 1 divided by 3 power 2. And one more term let us write. When you put n is equal to 4, it will become minus 1 power 4, that will be plus 1, and 4 power 2. And like this series continues. You can divide both terms by, both the sides by 4, divided by 4, divided by 4, right? So this 4 and this 4 will cancel. So you are getting pi square by 12 is equal to, and when this minus is multiplied with all the terms, this will become 1 over 1 square minus 1 over 2 square plus 1 over 3 square minus 1 over 4 square, and so on. The series will continue. And this is what they have asked you. This is the special series they asked you to deduce. So that deduction part nicely you have achieved using the Fourier series. Okay, so this is all for this video. I hope everything was clear. And in the next video, I will come again with some new topic. So till that time, take care all of you. Goodbye.